Hello everyone. Now we are going to discuss about the Matlab programming. For the fifth semester students, this is the enhancement ability program for the mechanical engineering students. Now I'm going to discuss about the what are the programs will be comes under this course. I will open the lab manual as well as the Matlab window also. And these are all the syllabus for the MATLAB program. These are the syllabus we are going to cover in the MATLAB. Same thing we are going to explain also. For these are the textbooks and course objectives. Okay. Anyhow, for this MATLAB programming, we are going to cover these programs. Okay, this is the MATLAB programming. Introduction to the MATLAB program. MATLAB is a high performance language for technical computing. And these are the basic commands: clear command, help command, look for commands. Clear command is used to remove all variables from the workspace. And this is how the MATLAB window looks like that one. This is the command window, current directory, and command history window, this one. Then these are the mathematical expressions we are using in the MATLAB programming. For the sine trigonometric function, we have to use sine of x. Similarly, tangent tan of x. For the square root of x, for the square root, we have to write sqrt of x. Likewise, these are the sub functions we have to use in the MATLAB for the mathematical functions. Next, for the plotting things, I'm going to explain using the MATLAB. This is the MATLAB window, online window. Anyone can log in through this window. It is freely available in the MATLAB website. So I will going to run this one. Just this is the x-axis and this is the y-axis. Just put on the plot x comma y and run it. Here you can see that one for the x-axis 1, y-axis is 3. Similarly, for the x-axis 2, y-axis is the -1. Likewise, the plot is drawn here. Next, we will go to that one. Next, for plotting the things for the x-axis and y-axis, suppose you have to give the label, then you have to give like that one, x label, y label, as well as the title. If you give like that one, that will also what display in the output. Run it, editor, click on this one, run. Here just x label, y label, and title will become title plot of the sine function, and what is the x-axis and what is the y-axis that is going to display by like that. Next, suppose you have to do for the multiple data sets in one plot, you have to go for like that. Multiple data sets in one plot. Hence, this is x is same for y1, y2, y3. Just I will remove this one and I will paste it and I will run it. I can click on the FI also. So this is the x-axis. Y1, Y2, Y3 is shown in the different color. See here in the previous one, I explained how to display the x-axis and y-axis as well as the plot time. And for the different curves, you can do for the different curve as different color also. Here you can see that one. You can see that one here. Y label as well as X label. Okay. You can get like the plot like that. We'll go for the next program. See for the different color as well as the different um, symbol, you should use this code. K means black, R means red, B means blue. Just I'm going to show once again that one. See, for the red color line, we have to use that what they mentioned, that one we have to use. Here you can see the Y should be is what sorry, X should be what discontinuous line, continuous line, and you can see the dotted line. That is by using this one. Okay, now we will go for the next program. Working with the matrix. So this is the matrix A. For feeding in the matrix A, we have to use like that. We have to write the command like that. If you write this type, you can feed to the matrix. Okay, just I will run it. I will run this one. The answer will be shown here. Okay, the answer will be shown here. Okay, next. For the transpose matrix, just you have to click the A, A, A dash, then you can easily do the transpose of that one. Inverse of A of this matrix, just you click on the inverse of A, the code, the command will convert the matrix into inverse of inverse matrix. And next to the matrix arithmetic operation, addition to the power as well as the multiplication, you can use by using these commands. Suppose if you go for the array arithmetic operation, you should use the dot star, dot division, dot power. So these are the operation can be do by the matrix. And next, very the simple thing, Matlab program on solving the linear function. This is the linear function. We have to find out the x, y, z, and here is the code is there. First, we have to write the A matrix as well as the B matrix. A matrix means coefficient of the x, y, z, and B is the coefficient of the RHS. Same thing, I'm going to copy that one and paste in the paste to the Matlab program. So this is the A matrix, B matrix, and I will going to do this one. Or the XYZ will becomes run this one. Here you can see the X is -1, Y is +1, Z is 0, 0. So this is the linear function solving using the Matlab program. After solving the linear functions, linear equations, and next is the control flow. If conditions is there, if else conditions is there, we can solve the if condition, if else conditions. all those things. The same way the program will be written, and we have to going to find that one. Okay, we will solve one if else condition also. I'll copy that one. I'll paste it here, and I will run by clicking F5. Here, what is ABC is there, b square minus 4s display x is equals to display x. If x is less than 0, display warning, else. Okay. The roots are real. The answer is coming here. A value is 8, B is 100, X is the root came this one. The roots are real, but maybe repeated. Here, the Matlab program is for what? If else condition. If else condition. Next, if else conditions. You can solve that one. Loop, for loop, while loop, we can solve in the Matlab. Just we will going to solve this one also. Write a Matlab program to find factorial 10 using while loop. Here is the program. Just I'm going to copy this one, and I will run in the Matlab window. I'm going to finding factorial 10 using while loop. Okay. The final answer is this much. Just I will go for the 3 factorial 3. 3 means 3 into 2 into 1 6. The answer should become 6. Whether check whether the program is running correct or not. Yes. See, the answer is the 6. 3 to the 6. Now we'll go for the other things. Then numerical methods and their applications. So this is what curve fitting by a straight line method as well as by polynomial method. This is the sample data, and we have to write a program for a straight line fit method. I will directly run this one. I will go to the software part. I will solve the straight line fit method. I'll copy the code. So this is the our sample data, and this is the straight line method. Okay, and I will run this one. See, here you can see the dotted. This is the x-axis and this is the y-axis. 1 2 3 4 5, and for the y-axis, for the x is equals to 1 2, x is equals to 2, y is equals to 4, x is equals to 3, y is equals to 5, x is equals to 4, and y is equals to 4. This is the what? A polynomial fit for this by using straight line method. Now we are going to discuss about what? Same thing for the polynomial method. This is the curve fit by straight line fit. Next one is the polynomial fit. Same sample data. Same sample data. But this method is the polynomial method. Here we have to choose the which degree I want, 2, 3, 1, like that. I will run this one. I will give the degree as the 3. Same points, but the curve fit will be the different. You can see that one. The red color shows the first method. That is what straight method. Next is the curve method. Here I'm going to change the values right now. I will change the values 3 to 4. Now you can see the fourth one is what almost matching the curve. Just I will close this one and once again I will run this one. You can see very clearly. See, for the degree 4, the curve is clearly matching the given points. Suppose this is the polynomial method, curve fit method. If I give degree is equals to 1, it becomes the straight line method. Here you can see the straight line method. Okay, just now we discussed the straight line method as well as the polynomial method for the curve fit. We'll go for the other things. Next experiment. Curve fit is also is over. Next, we're going to discuss the numerical integration. Here we are going to use you will use this function for the numerical integration. This is what integration from 1 to 2, 1 over 1 plus x into dx. This is by numerical integration by trapezoidal method. For this program, I am using this problem 1 over 1 plus x into dx for the integration of 1 to 2. I will share that one. Just I will close this thing. And this is the what I explained that one. I have to enter the lower limit as well as the upper limit and subinterval. Okay. Just I will run this one by clicking Y. Here I have to type in the command window 1, enter the value limit of value 1 and enter the upper limit B 2, B becomes 2. Next subinterval I will give it as the 10. Here you can see that the value of the integration, how much it is came, 0.40 is the answer. 0.405581 is the 81 is the answer. This is by the what trapezoid rule. Same thing we are going to solve by the Simpson methods also. Once again, I'm going to take that code also here. I will take that code. Simpson's 1/3 rule. I will just will delete the old code. I will run this one. Here, this time, the problem is the different. Second type we are taken here. I will run this one. First, enter the lower limit here. Once again, the lower limit and upper limit is 1 and 2. 2. Enter the subintervals. I'm going to type it as the 10. The answer is 4.04 for this problem. So the numerical integration by trapezoid rule as well as the Simpson 1/3 rule is over. Next. Next is Matlab program to find the linear algebraic equation using Gauss elimination method. So the next problem is what linear algebraic equation using Gauss elimination method. Next, I will take that code and I will share that one. Okay, this is the input matrix A as well as the RH of the system, Gauss elimination method, F5. Directly the solution will be comes. Directly the solution will be comes to solve the linear algebraic equation using Gauss elimination method. Next is nonlinear algebraic equation using Newton-Raphson method. Newton-Raphson method. I will take the code. This one is for the Newton-Raphson method. Here, this is the function. Here, the values have to be given here. And if else condition, while loop conditions, all those things are already explained. I'm going to run this one. See, the answer is taken 5 iteration, and the root we got it as the 2.7406 for this problem. After the Newton's Raphson method, the next program is ODE equation. ODE, ordered differential equation. Once again, I will take the code. And paste it. This is the ODE equation. This is the problem. And we have to input the value of x, y of x, and step size, and at which y is required. Those data we should give. Run this one. I will give x is equals to 0, y is equals to 1, x is equals to 0, y is equals to 1, and the step size I'm going to give it as is 0.025, and the x at which y is required is I'm going to give it as the 0.1. The solution is displaying here. The output value we got it as 1.093264 for this problem. Okay, this is the how we are going to solve the uh, MATLAB programs for the different types of problems. Thank you for watching.